Hi guys. Today we're going to discuss this so-called proof that 2 is equals to 1. There are a number of proofs like this floating on the internet. They all seem to be making a use of one particular, let's say, exploit that you strictly speaking not allowed to make use of, and hence you obtain this, or you can obtain this bizarre false proof. So we're going to do the proof, or should I say proof in quotes, and we will see where exactly it breaks down, and then we'll say a few words about how it breaks down and so on. So let's make a start. Let's assume that A and B are two real numbers. Let's assume that they are identical numbers, and let's write down a series of equations that will allow us to conclude that 2 is in fact 1. So let's start by saying, by putting an equation A equals to B, because we know that we have to start with identical numbers. From here, we will add the same things to both sides. So we will add 2B to the left-hand side, and we will add 2A to the right-hand side. Since I know that A is in fact the same as B, then I have added the same things to both sides of this equality, and hence I haven't changed it. We will proceed in the same way by adding another number to both sides, and we will add specifically minus 3b. And after adding it, we will combine then terms that contain b together. So we will, for instance, on the left-hand side, we will add 2b and minus 3b. And on the right-hand side, we will add b to minus 3b. After completing such addition, we will get an equation of the following form. We can pull 2 out on the right-hand side, and we will get something like this. And so we near the end now. We can surely divide by a minus b at this point, right? Because we are certainly allowed to do that. So we'll divide by it. We will divide by it, and after dividing both sides by a minus b, we obtain the advertised result that 1 is in fact the same as 2. Who would have thought, right? I mean, all our lives we've been told that 1 and 2 are different numbers, and it seems like we've all been lied to, and 1 is in fact the same as 2. Well, I mean, mathematics is broken. This is it. Well, unfortunately not. For those of you who are hoping that mathematics is broken and nothing can be done, this is unfortunately bad news. This proof is false, and we will see in a second why. I will see in a second why. I have removed an equation, which I shouldn't have done. So let's discuss where this proof breaks down. And the answer, some of you may have already spotted, is exactly at equation 6. So at equation number 6, I have told you that we will divide by a minus b, which of course I was not supposed to tell you, and in fact I was certainly not supposed to divide by it, because in fact I divided by 0. And those of you who don't know why we can't divide by 0, but most of you probably have heard that we cannot divide by 0, and hence, if we cannot divide by 0, we cannot go from equation 6 to equation 7, and hence we cannot conclude that that bizarre result that we got, the 1 is exactly the same as 2. So hence division by 0 has allowed us, it was that exploit that I mentioned at the start of this video that allowed us to do this false proof. Well, having now done this false proof, let's quickly discuss why exactly do we not divide by 0 and what is so bad about it. So I might release another video in the future where I will describe this maybe in more details, but as a short answer, we can say about division by zero something along the following lines. So real numbers, rigorously speaking, real numbers in mathematics are called a field of real numbers, or we can say that real numbers is what is known as a field of real numbers. Now, field is an abstract concept. It is essentially a set or a collection of elements, and there is a set of rules that these elements need to satisfy or need to obey. Right? And what exactly those rules? They're not complicated, but let's not mention them for now. We don't really need it. So in a field, we only allowed to do operations on the elements of the field. And this is really the key idea why we do not divide by zero. So I'll say it again. We only allowed to do operations, and by operations I mean arithmetic operations such as addition, multiplication, subtraction, and division. We're only allowed to do it on the elements of the field. So basically that means that if something is not an element of field, I cannot add 1 to an apple, right? Because an apple is not an element of a field of real numbers. So keep this in mind. That's the first thing. The second thing is, in a field there is really only two operations that are defined initially. This is an operation of addition, an operation of multiplication. Operation of subtraction and division is defined in terms of operation of addition and operation of multiplication. So when I say divide by 2, I really mean, and this is how it's rigorously defined, I really mean a multiplication by something known as a multiplicative inverse of 2. And what is a multiplicative inverse of 2? It is 1/2. A multiplicative inverse of 5 is 1/5, and the multiplicative inverse of 1,000,000 is 1/1,000,000. Yeah, so it's a very simple concept. So anytime we say divide, we really mean multiply by a multiplicative inverse. So when we say divide by 0, right, rigorously speaking, we say multiply by a multiplicative inverse of 0, right? And a multiplicative inverse has a property that, and then when you multiply it by a number with respect to which this multiplicative inverse has been taken, the result of this multiplication is 1. For example, if I take 2 multiplied by a multiplicative inverse of 2, which is 1/2, I'll get 1. And the same for any other number or any other real number. So when I say divide by 0, I mean multiply by a multiplicative inverse of 0. But this leads to a question whether a multiplicative inverse of 0 is actually element of the field or not. And the answer is, it is not an element of a field. It's just like an apple is not an element of a field of real numbers. Yeah, and hence you have no doubt understanding that you cannot divide 5 by an apple, right? It's an absurd, and hence you should not be surprised that you do not divide anything by 0, because a multiplicative inverse of 0 is not a member of a field of real numbers. Now, in fact, the precise reason why it's not a member of a field of real numbers is a short proof that can be done. We will not do the proof, of course, not today at least. But to mention one last thing, and the reason why the proof in fact can be done is based on the exact properties that 0 has. So if you think about it, a 0 has a very unique property. A property that anything you multiply 0 by gives you back 0, right? And one of the requirements of having a field is that 0 needs to be a member of a field. So if we were to have a multiplicative inverse of 0, then you can probably already see that something would be a bit strange. On one hand, we would have 0 multiplied by a multiplicative inverse of 0, and we would seemingly need to obtain 0, right? But on the other hand, multiplicative inverse of 0 would be a special number that multiplied by 0 which should give us 1, right? So there is something wrong, even non-rigorously speaking, even without doing any proofs. Hopefully you can see that there is something problematic about this, right? And of course, in rigorous mathematics, we do not like such problematic areas, and hence with a little bit more work, but reasoning exactly as I said, we can show that in fact the field of real numbers does not have a multiplicative inverse of 0, and hence by virtue of this argument we do not divide by 0, right? It is an operation that is not allowed, and in fact it does not exist, and it does not lead to any real number. And hence our false proof that 2 is equals to 1 is wrong, and the series of equations that we have produced, we should really have stopped those equations at equation number 5, right? All the way up until equation number 5, we have not broken any rule of arithmetic that we know and love, but onwards from equation 5, it all gone wrong. It all gone wrong. So this was a false proof that 2 is equals to 1. Thank you guys for watching, and I probably see you in some other videos in the future. Bye.